All right, so let's review a little bit of what we learned before. Okay, the last time we had talked about the quantum numbers. There were 4 quantum numbers.
I remember those.
Okay.
1, 2, 3, and 4. Oh yeah. 1, 2, 3. Wait, let me see if I remember.
I know there's one called like spinning. Spin. And there's one that looks like
Principal, angular, magnetic, spin.
flower.
Yes, but it's like 1, 2, 3, 5.
Whoa.
Oh, yeah, you got it. I'm taking it home.
It's me and my killer.
I offer them.
Give me a sip.
It tastes like garlic.
Ew, why
Principal,
would
let
you
me
eat
have
that?
some.
That's gross.
Mountain Dew rice. Blueberry pomegranate.
Blueberry.
Are you guys doing the English chapter and stuff?
I'm not a fan of.
I'm not a fan of Mr. Quick calling me out for not writing sentences. He said, for people that don't read the directions, or for people that don't seem to understand directions, it says write these sentences. Because I wrote nothing.
All right.
Okay.
Mr. Schmeltz, can I come in or do you want more?
No, page 111 is where we're going to go to, but the quantum numbers are found in your book on pages. They're on pages 107
You said no, I said yes.
to 110.
Okay.
So reviewing, what did the principal quantum number tell us?
That told us.
What does that represent?
It defines the energy levels where electrons are most likely found. Literally. What? Yeah.
So your energy levels, this just goes from 1 to 1, right? They're just the first energy level, that's the one that's closest to the nucleus.
I already wrote this stuff down.
Yep, I'm just summing it up to get everybody on the same page. So you should already have this stuff. I'm just kind of reviewing it, putting it in a nutshell.
My notes are so bad.
What was the next quantum number? What was the next quantum number? that we talked
Angular.
Angular.
about? Angular
momentum.
momentum?
Evelyn, look how big you.
I like mine.
It's hard.
I like mine better.
Okay, what did that really show us?
Define the sublevels.
Sublevels.
Raise your hand next
I don't raise my hands.
Okay, and we represented that with an L, right? And what were my possible values for that?
Okay. That was 0, n minus 1, 0, 1, 2, n minus 1.
Right, you started at 0, right? And still used integer values. But your maximum value the maximum value you can go up to is n minus 1. So whatever energy level you're in, subtract 1 from that, and that's the highest you can go for your sublevels. Right? So if you're in the second energy level, you can only have 2 sublevels, right? In the second energy level. You can have 0 and 1 because your maximum value would be 2 minus 1, which is 1. You have to stop there. That makes sense? All right. What was the next quantum number? Magnetic quantum number.
You have these one month.
And what did the magnetic quantum number define?
That defines the number of orbitals per sublevel.
Orbitals, right?
No, I heard those.
You asked what I heard.
So the magnetic quantum number shows us the orbitals, right?
Yeah.
We represented that with an M sub L, right?
Yeah.
What are the possible values there?
Negative L.
Right, so you have to know what your L value is, right? You have to know what your sublevel is. And that defines how many orbitals will be in that sublevel. So you start at negative L and you use integer values until you get up to positive L. Okay? So if your L value, for example, is 3, you'd start at -3,
Oh, yeah.
-2, -1, 0, 1, 2, 3, right? That tells you that there'd be 7 total orbitals in that sublevel. Okay, also keep in mind that your sublevel values, we defined them as S, P, E, F. Okay.
Sorry.
Guys, go. S, P, D, F, that's as far as we're gonna go with the elements that we know. You could keep going, the next one would be G, the next one would be H, but we're not gonna ever use those because the elements that we currently know of in their ground state are never gonna go above them. Okay. So that just tells you how many orbitals there are then within the sublevel. So again, for the elements we know of, you're not going to go above 3, the value of 3 for L. That'll be your maximum. Doesn't mean that there aren't any higher than that, there are. But in the ground state, our current elements don't do that. And what's the last one then? Right, the spin quantum number. Which just defines direction of spin, right? And your possible values for that then are what?
-1/2.
So did I.
So it's either going to be a -1/2 or a +1/2, depending on which way it's spinning, right? It's been one direction or the other direction. And remember, when it spins, that's what gives it magnetism, right? It's kind of like the Earth is spinning as it goes around the sun, has a north pole and a south pole. So one electron is spinning one direction, and the other electron that's in that orbital will spin the opposite direction, because then it'll have magnetic attraction to cancel out the electrical repulsion. Okay. So that kind of brings us back to where we were. I know you guys are probably getting reading about this stuff all
Oh, yeah.
weekend, but I just want to be sure we're all on.
Yeah. Oh my God.
I'm gonna tell my mom.
I just,
All right, so
put up my
rules
medical card.
governing electron configuration. And all electron configurations are, we're just defining what energy levels or sublevels and orbitals the electrons are in. And there's certain rules that we have to follow to govern that. So electron configurations are just assigning electrons.
It's interesting to know.
It's really just coming from the quantum number values, right? We're just saying, okay, this electron's in the second energy level, it's in the S sublevel, it's in this orbital, and it's in that, it has that direction of spin. Okay, but there's rules that govern these electron configurations. The first rule is what's called the off-ball principle.
Ball.
I think it's a term that comes from a Greek word. I can't remember what. I think it's a Greek word. Off-ball. AUFB.
That's what they used to call me.
But all that means is, it just means building up. That's what off-ball means, is building up. So all it means is, when electrons are filling in around the atom or around the nucleus, okay, when electrons are filling in around the nucleus, they're going to fill in the lowest possible energy sublevel first before they start filling up the next one. So all that's saying is you're just going to fill up in order of energy. Okay. And if you look on page 111 in the book where I showed you, there's a little chart down there on the bottom right on page 111. That shows you the order of energies of all the different sublevels. So the very lowest energy is the 1s. That means those electrons are in the first energy level, which only has an s sublevel. Okay. Once that's filled in, then we can start filling in the 2s, okay, which is the s sublevel in the second energy level. Then we can fill in the 2p, okay, which is the p sublevel of the second energy level, and so on. We just keep going up that chart. You will notice there's some overlap, right? When you get up to 4s, or when you get up to 3p, the next thing to fill in is 4s, and then 3d. There is some overlap as you go up through. So you have to use, I'm going to show you an easy way to remember that order, so you don't have to memorize it. For right now, you can just use the chart. That just shows you the energy. So electrons fill in lowest energy sublevel. Okay. So in other words, they're not just going to start filling in randomly. Okay, they're not just going to start jumping in 3p and then 2s and all that. They have to fill in from lowest energy to highest energy. That's all the optimal principle. I know these names are weird. Hund's rule. I refer to this as the bus rule. So if you're getting on the bus for a really long trip on a bus, you probably want as much space as you can have, right? So you're going to try to get your own seat. So you can spread out, stretch, whatever, sleep. Okay. Well, what Hund's rule is saying is if there's more than one orbital available in a sublevel, the electrons are going to occupy the orbitals one at a time before they start pairing up. Sort of like when you get on the bus, you're going to try to get your own seat. But if you get on the bus and all the seats are occupied, now you're going to have to start pairing up. Right? So electrons will not pair up in an orbital until all orbitals are occupied by an orbital. So even if you really like somebody, you're still going to take your own seat. Until all the seats have somebody in them, then you can start pairing up. Okay. Now, in an S sublevel, if you notice on page 111 there, if you look down the boxes, anytime you see an S, how many boxes are there? Just one box, right? So that's like a two-seater car, sports car. You got your driver, okay, and then you have to pair up in the passenger seat because there's no other seat available, right? What about a P sublevel? How many boxes are there in a P sublevel? 3. Okay. So that's like a minivan, right? You got 3 rows, or an SUV. Minivans are cooler. So you got 3 rows, right? In each row, you can have 2 people. So what would happen there is the driver gets in first, right? Hopefully. And then the next person's going to go into the second row. The next person will go into the third row. Then we'd start pairing up. So the next person would then pair up with the passenger seat, then the second row. That makes sense? Okay. D sublevel has 5 seats, right? So there we got the extension van, right? School vans where you have 5 rows. And the same thing. They just each take 1 in each row. That's Hund's rule. And the third and last rule
Oh, yeah. Look at that.
is the Pauli exclusion principle.
I hate, like,
Wait,
we hate.
like from Jersey Shore.
Sure. P-A-U-L-I. I have no idea.
Probably like, probably won't be
It's
forever.
T O D.
And what that tells us is no two electrons in the same atom have identical set of quantum. So what that means is you could have two electrons that are in the same energy level. They could be in the same sublevel. They could be even in the same orbital, but what would have to be different about them? So what did we say? If they're in the same orbital, normally they repel each other, but what do they do so they don't repel each other? They spin in opposite directions, right? So if they're in the same energy level, same sublevel, and same orbital, they'd have to spin opposite directions because that opposite spin is what gives the magnetic attraction to counteract the electrical repulsion. So 3 of the 4 numbers can be the same, but not all 4. If you'd put them in the same orbital and they'd also be spinning the same direction, there'd be so much repulsion because they repel each other electrically and magnetically. There's no way they can occupy. They have to spin on. That makes sense. So what I want to do is use these rules to start representing electron configurations for electrons in atoms and assign quantum number values to each electron in them. All right. So it takes a little while to get the hang of this, because once you get the connection, it's not too bad. That's should think it's easier as you get the. So everybody done with that?
Yeah.
Okay.
I'm gonna keep that stuff up because I'm gonna keep referring to that.
What is that?
Which one is it? The first one?
Wait, when is it?
It's April. Hang on. It's the one in Philadelphia is May 6th. May 6th and 7th. Well, I read
This is as good as it gets. I don't know why it's food.
Don't you have spray?
It's 10 a.m.
I do, but I'm not gonna keep spraying on it. That's good enough.
Mr. Smells, we won't be here.
Friday, I'm
May
really like occupied in buying tickets to a concert. Like, I don't know.
All right, let me just go through some examples. Because it's easier to kind of get the hang of it as you see me doing examples, and then I'll have to do something.
I have a screenshot. Yeah, normally it's either you have to be vaccinated or you have to provide an ID. I can provide an ID. It says all fans, welcome home, must provide proof of vaccination.
All the time.
Not vaccinated.
I'm 9 and guys, Emily, you asked her.
So oxygen is number 8 on the periodic table. Its atomic number is number 8. That's what that Z means. Z equals 8. Remember, just like when we were doing the mole equations. So what I want to do is I want to write out what we call an orbital notation for each electron in oxygen to represent each electron. And I also want to assign quantum number values for each electron. Okay, that's why I've kept these up. So I'm just going to put 4 column headings. I have 8 electrons. So that means each of those 8 electrons has its own set of quantum.
Oh, no.
It's horrible. It's not. It's fun. You're gonna love these. You're gonna have so much fun doing these. You're just gonna go home and keep doing it.
Now, we're gonna.
Probably gonna paint your room in that whiteboard paint just so that you can keep doing electrons.
Oh, I have chalk.
What if I just don't?
You're
Right.
shutting it, man.
So, off-ball principle tells us that the first electron that fills in oxygen has to occupy the lowest possible energy sublevel, right?
Yeah.
So looking at page 111, what is the lowest? 1s, right?
Oh.
So that means we're in the first energy level, right? The 1 tells us the energy level. The S tells us the sublevel. So the first electron is in the first energy level.
Yeah.
Okay, if I'm in the first energy level, what's my only possible sublevel? It goes from 0 to n minus 1. What is n minus 1 if I'm in the first energy level? 0. My only possible value is 0, right?
Yeah.
Which represents the S sublevel.
What's local? I
ML goes from negative L to positive L. Well, my L value is 0.
Yeah.
Is there a negative 0, positive 0?
Not so it's 0 again?
So it's just 0. That means there is only one orbital, right? Which on page 111, that's why they only have one little box, right? That's representing my S orbital. Now I have to assign it a spin, right? So I usually start with -1.
Okay.
So that's my electron that's occupying in that orbital. Now, another electron can go in that orbital, right? But what has to be different about it? Its spin. So my next electron is still going to be in the first energy level, S sublevel, S orbital, but it's going to spin the opposite direction. When I'm used, this is my quantum number values, right? I also said, let's write the orbital notation. When you write orbital notation, it's similar to what they're doing with those little boxes. I just use a line to represent an orbital. Underneath that line, I just put what sublevel that orbital is in. Okay, this is my electrons that are in my 1s sublevel. And then each electron is represented with an arrow. And the arrow represents the spin. So one of my electrons is spinning one direction. The other electron is spinning the other direction. That's my positive 1/2 spin.
Oh, not that.
But that's all I have in that sublevel, right?
I gotta be honest, I don't get it.
We will get it.
I'm in the first energy level, right?
Yeah.
which means I can only have an S sublevel because my maximum value is n minus 1, which is 0. Which means my only orbital value is 0. Okay,
Yeah.
because in any S sublevel, I can only have one orbital. But I can put 2 electrons in any orbital. And one spinning one direction, one spinning the other direction. So that represents my first 2 electrons. Okay, of my 8.
So we end up having
You're gonna have 8 rows.
like, are the.
Well, you'll see. Hold on. Okay, we're gonna have 8 total values, right? 8 total rows. All right. What comes next after 1s?
Who else?
2s, right? So now I'm going into my second energy level.
Okay, so then L will be 1.
Now here I have 2 possible sublevel values, right? 0 and 1, because 2 minus 1 is 1. But 0 is lower in energy than 1. Okay, so my next one, I'm going to be in the 2s. Any S sublevel has about L value of 0. Which means it can only have one orbital, right? My first electron is going to spin one direction. Then I'm just going to pair that electron up.
Okay, I guess this is chill.
So again, I only have one orbital, right? One
So
line.
is that just saying like the level that it's in on the bottom and then the direction on the top?
Yes, the spin direction.
Yeah. Okay.
I just draw one line for each orbital. That's in that sublevel. So since an S only has 1 orbital, and we draw one line.
Yeah.
Okay, but now I also have a P sublevel, right? In my second energy.
Oh,
level.
no.
So my next, I took care of 4 of my 8 electrons. The 5th electron now is going to go into, still in the second energy level, but now we're going to start filling in the P sublevel. P sublevel has an L value of 1. Well, what are my orbital values if my L value is 1? Let's start at what? Negative 1, 0, positive 1. So my first orbital is my negative 1 orbital. Now remember, Hund's rule comes into play here, right? This is my 2p sublevel, right? And there's 3 orbitals in my CP, in my 2p sublevel. Negative 1, 0, and 1.
Yeah.
So each of these lines, this just represents L equals -1. This one represents L equals 0. And L equals 1. Okay. But remember, Hund's rule said they're not going to pair up yet, right? They're going to each orbital has to have an electron before they start pairing up. So the next electron, still in the P sublevel, right? But it's going to go into the next orbital. Okay. And when they go in one at a time, they spin the same direction. They don't spin the opposite direction until they pair up. So there's my next electron. And then the next one, still in the 2p, right? 2p. But this has a value of 1. That's that. I took care of representing 7 of my 8 electrons, right? I only have 1 more electron. Okay, that electron gets into the minivan and says, oh, each row has somebody, right? So now I have to pair up. So that's going to pair up here, but what has to be different about it is it just has to spin the opposite direction. So I'm back in this orbital, right? this orbital. But what has to be different is it has to spin the opposite direction. So that represents the two electrons. They create the same energy level, same sublevel, same orbital, but they're spinning. And I'm done because I represent them all. What's that? Right, that's where I stop. It's also. Got fully electrons. Now there is another notation. Orbital notation is nice because it gives us a nice visual of where all the electrons are, and their spin is. But if I had uranium, which has 92 electrons, that might get a little hot. So there's also what we call, this is the orbital notation. There's also what we call electron configuration notation. And all you do there is I still write the sublevel like 1s, but I use superscripts and I show how many total electrons are in the sublevel. Okay, so how many total electrons are in this 1s? 2. So 1s2. How many are in my 2s? And in oxygen, how many are in my 2p?
Okay.
So a little more condensed, it just doesn't give us as much information. And we are going to learn even shorter notation as we go on. Right now, we're good. So what I would like you to do is do the same thing for
No.
aluminum.
How many did they do? Who said that?
Fucking 13.
What the F? No, it's not.
Now, you can kind of just pick up where you left off, right? Because the first 8 electrons of aluminum are going to have to be the same value.
Oh, really?
Because you always start at the lowest and work your way up.
So now we're gonna.
Well, we didn't fill up the 2p yet.
That's not.
Oxygen just didn't have enough electrons to fill it up. Now you have aluminum, so you're gonna have enough electrons to fill up the 2p sublevel. Well, how many spaces are still available?
Oh.
Right. Pair these up, right?
Oh,
The next
yeah.
two, we're gonna pair these up. If you can do that, we'll look at it.
Yeah, we would.
Pause. Aluminum has 5 more electrons than oxygen, right? So we already represented the first 8 electrons.
No, don't worry. I'll explain it all.
That's Florida. So right.
So the next electron now is going to pair up in this orbital, right? We already paired this one up. Now these two have to pair up.
Oh, yeah, they do.
We're still in the second energy level.
Uh-huh.
We're still in the p sublevel.
Yeah, we are.
We paired up the -1 orbital, right?
I know what it is. Oh, I know.
Now we're going to pair up
This
the 0. And that'll
Oh,
be
yeah,
positive
it is.
1/2, right?
Oh, yeah.
I got this. I don't understand.
I bet you I can do the next one. All right, guess what? I can just read out the next one.
2, 1, 1, 1, positive 1/2.
2, 1, 1,
And
positive 2, 1.
right, 2, 1, 1.
I got that right.
Right.
I didn't know.
I
what to
didn't do
do
it.
That's where I got lost.
What?
2, 1.
Remember these 3 orbitals, remember we said that those are the peanut shaped ones. So one goes along the x-axis, one goes along the y-axis, and one goes along the z-axis. So this is like your px, your py, and your pz. Okay, remember we said it just describes the orientation of those orbitals around the nucleus. Okay.
Where's the gun?
So the L equals -1, that's your px. The L equals 0, that's your py. The L equals 1, that's your pz.
We need to get up and.
Is Ava
Okay.
Snyder?
All right,
She's in force with that. What do you think?
after 2p, what's the next one?
Oh,
Big
three,
one?
three.
Three S. So
See, I messed up with. I don't think I messed it.
Yeah.
I love you, Tay Tay, but.
Should I go see Jake Paul fighting? Jake
all
Paul?
right, how many orbitals are there in a 3s? Look at your little
Zero.
box. The only value is 0, right?
Yes, he knows.
There's only one little box that's showing on page 111, right?
Yes.
Page 111.
Yeah.
All right. So I'm in the third energy level, right?
A third, and then the L will be.
My possible L values are 0, 1, and 2, but you always start with the lowest, right? 0,
Yeah.
which means how many orbitals are available? Just the 0 value, right? One orbital, which has a value of 0. So that's my electron that's spinning that direction, right?
I know, I'm straight up like it's not an arrow.
No,
What are the arrows?
you gotta figure out all the.
That's just showing the direction that your electron's spinning. One's spinning one direction, the other one's spinning. All right, so my next electron's got to pair up in there, right?
Can we?
So that's that.
I want the work period.
All right, now I've taken care of 2, 4, 6, 8, 10, 12 of the 13 electrons,
I'm so
right?
excited.
I only have one electron left. I already filled up my 3s, right? So now I'm ready to go into my 3p, right?
3, 1, -1, negative half.
So now my L value is 1, right?
Yeah, I guess so.
Means my ML value starts at
Negative.
-1, or negative, yeah, -1.
You said helicopter. That's what you said.
How many little boxes are there at 3p?
There would be 3.
Right, so I'm gonna draw my 3 lines, but I only have one electron for aluminum to go in, right? I ran out of
So
electrons.
if there was more, you could, it would
Then
have
you-
6 in there.
Yeah, so if you kept going.
Yeah.
If you kept going, it would be, the next one would go here, the next one would go here,
And then
they'd
you would
pair
fill
up.
it.
Okay,
I kind of get it. But if we're doing this for homework, I won't get it. This is you know
All right.
what? It's not my decision.
so what I would like you to do,
Oh.
for homework or practice or whatever,
Oh.
is I want you, well, I'll do an example first of what I want you to do, and then I'll sign it. All right, questions on that before I?
I guess.
No,
what? I think I'm
I
good.
don't understand.
Everyone take your screen.
I took a picture of it earlier.
Wait, screen. It's screen.
All right, I'll just do a,
No, we need a screen.
This is from this makes no sense and I will. Also,
Maybe.
when are we finding out about the other testicles?
Oh, yeah, the people.
oh, I didn't get to this.
Take your time.
We took
No,
that too.
I actually have to take one.
if you take too much time, you have to give us one.
I have them in with my.
Every single day you have to give me an extra 10% credit.
other time.
Yeah, every day you forget to do it, add 5 points.
I'll get them.
Yeah,
Okay,
if
well,
they're
that
not
means
here tomorrow,
it's
5 points.
I'm
All
expecting
right.
100.
We're unionizing.
Let's say,
No. I was talking about
Tennis.
Let's say, I don't think we will play tennis.
I would rather be.
right, I'm gonna leave
I would
that
rather
up
be
there,
back-
but maybe erase all the fun.
okay.
That is a lot.
What? She said, I'd rather get vaccinated than do math.
This is not bad.
Everyone watching this has.
They are.
Guys, guess
I
what?
think everyone knew, like,
Guess
in
what?
9th grade, remember that big debate we had?
Oh, I don't remember.
All right, let's say now,
Oh, I do.
Wait, what happened?
I want you to,
Carl. Everything go back. This is really not
Hey,
nice of
chocolate.
me. Okay,
Write the orbital
in electron configuration.
It's horrible when you don't understand.
Notation for
For
zinc.
nickel,
Zinc.
which is number
Stop.
28. That is,
Oh, God.
There's 28 of them?
What is not Tokyo Pop? What does?
Notation.
Oh.
That's
That's not an A.
so because I don't want you to assign, once you start getting to higher ones, it gets kind of monotonous to keep putting 4 quantum number values. So I'm gonna say, just give me the quantum number values for the D sublevel electrons. Okay. But let's first finish out the orbital notation and then we can go from there.
I guess.
All right,
I'm still
so
writing.
now I have 28 electrons, right? That I have to represent.
Oh, what I got?
I already got the first 13 here, right?
I guess.
So where's my 14th electron gonna go?
It's gonna be no, it's gonna be.
They won't pair up
Last
until
Oh, it's gonna be
every
the
orbital
second
has
one.
one in. So my next one goes here,
Up,
the next one goes here,
up.
and now they're gonna start pairing up.
spinning.
right?
Spinning in pairing. Spinning in pairing.
All right,
Like, just like saying, like, I already understand. Okay.
so that took care of my first 8. I'm up to 18, right?
Oh my God, that is hard. We're up to
Next,
18.
we're going on to 4S.
Right. If you look at your page 111, after 3P comes what? 4S, right?
Ew.
The 4S actually fills up before 3D. 4S is actually lower in energy than 3D. There's like overlap of energy levels.
That's like crazy.
All right, so if I have an S sublevel, how many orbitals are there?
0.
The only value is 0, so it means there's just one orbital, right?
She meant that.
I knew what you meant.
So,
Maybe you should be quiet.
So I only have a single orbital. If you look on page 111, there's just one little box there, right? with the
Yeah.
4S.
yeah, I guess so.
So I'm just drawing one line.
Oh, yeah.
So my next 2 electrons, that's a 2-seater car, right? So there's no option. Driver gets in, and then the passenger gets in. Okay, now I'm up to 20.
I guess that's 4S.
Now I have to do my last 8 electrons. What comes after 4S?
4D. 3D.
Oh,
3D, right? 3D. How many orbitals are in a 3D or in any D?
3, 4, 5.
Okay, how many little boxes are there for the D? 5.
Holy wow. This is messed up. Like, no, like actually I'm.
Right?
And then it goes up and down. Up and
I have
down.
8 total electrons that I have to put in there, right? Because I've already filled in my first 20. So they don't pair up until they have to, right? This is where you take your own seat.
Oh wait, I get this.
And now the next
The first
3,
3 are down.
right now the next 3 get in and they're like, oh, I have to pair up.
Double connect. Or like, I have to say what weird out. It depends on how many. Bam.
and I ran out of electrons. Right?
Yeah.
He's out.
It's always sad when you get to the last electron.
No,
I have to agree. Okay.
not really.
And now it's embedded in the notation. So that's orbital, right?
That's the orbital notation. So all you're gonna do for the electron configuration notation is just write this, but use superscripts, right? So how many are in my 1s? 2. 2s, 2. 2p, 6. 3s, 2. 3p, 6. 2. And 3d, I only have 8 electrons in there. It can hold up to 10, right? But I only have 8.
Oh, okay.
All right. The last thing that I asked you to do, was assign quantum number values
No.
for the electrons that are in the D sublevel. So I'm just gonna focus in on these.
This is like horrible. I don't like
Well, what energy level are all 8 of them in?
3.
The third energy level.
Ew.
Why are there so many trees?
Because there's 5 spaces and there's gonna be.
I've got 8 electrons in here, right? Every arrow is an electron, so I have to represent all 8
I'll
electrons.
hate Q's nowadays.
What's my L value for a D sublevel?
2.
2, right?
2 all the way.
That was my 3s. That was my 3p, right? So 1. Now I'm in the 3d, so my sublevel value for all 8 of those electrons is 2. If my L value is 2, what are the range of my orbital
-2,
values?
-1, 0, 1, 2.
Right,
Yeah, that's a lot.
so I'm gonna start at -2, right? My values go from negative L to positive L, right? So my L value is 2, so I'm gonna start at -2, -1, 0, 1, 2.
And then do we, and then.
That's where they went in one at a time, right?
Yeah,
And now they're gonna start pairing up, right?
and so it's the opposite spin, and it's just the same thing over again.
Right. There was only 3 of them that paired up to them, right? So this one, I just repeated the first 3. So when they went in one at a time, they were all spinning this way.
Yes, they were.
This way. The last 3 are positive.
Now they're pairing up.
Ooh. Sorry, my toe itch. I was lying. Who believed? Guys, who else believed?
You don't have to draw those lines. I'm just showing you they're
Yeah.
connecting because they pair up.
Yeah, I really. Okay.
Is it over now?
Does that make sense?
Yes, I suppose it does. No, it
Because
does.
unfortunately, that one's over.
Oh, yeah.
Sled.
That's the
So-
adjective I would.
Your assignment,
Oh, please come. What?
Boron. Would you boron?
Oh, no.
Can we do hydrogen?
Let's
do the biggest
zinc number. What? Oh, no. What's the biggest,
It's infinity.
we're gonna do germanium.
Oh,
No, boron.
because this is.
Germanium's number
32.
32.
That's what I'm saying.
Oh, it's only 4 more.
Right.
Okay. And then
But
so
this
it's-
time you're gonna assign the quantum number values to the 4p electron.
What's the 4 piece?
This ain't meant to go.
So you're just gonna continue on with your
Yeah.
orbital notation and electron configuration notation. You only have 4 more, right?
Yeah,
We already did the first 20.
I guess.
And so the first one we're placing 3D, right? Yeah, and then we'll have 2 into 4P. I didn't figure it out.
Can you
So 2 electrons and 4P.
That's what you end up with.
Yeah.
Mr. Smells, can you help me? Sorry, I'm lost.
I got a video of this lesson, guys. Let me see it.
So. What are we going to do?
Well, you have to first fill up the 3D, right? There's still space for 2 more electrons. In 3D. It's 2 of them.
Should I rewrite this?
Yes.
And then is the notation what's down there?
The electron configuration notation is the 1s2, 2s2.
Yeah. So we would only have to add, we'd have to change the 3D and then add.
Yep.
Okay. I'm done. This is right. Only.
Again, I don't understand it.
Did that?
Oh,
and
yeah.
that, and that.
Yes.
Wait, how many do we need? You only need four. So it's like just left the first two will be and then 3D on the second. The 2 more would be the 4.
They're both.
All right.
Oh, yeah.
Oh, yeah, they don't. Because you're gonna.
Right.
Yes.
Okay, I wrote all of it down.
So I think I have the chart thing, but I don't know how to put it in. Can I go fill my water bottle? No.
Mr. Smells, can you come okay, I wrote it down, so now I need it.
See, what would be my mom?
So I would.
Oh,
fill in-
my.
So this.
So that's gonna be your 20.
Smell you later.
Ew.
And then after 3.
Yeah.
P sublevel is 3 lines. Well, you have 2 electrons.
So they don't have to fill it. So then, that's it. Okay, so then I just word it like.
Okay,
That's pretty.
yeah.
Wait, would that change to 3D to the 10?
Yep.
And then 4P.
Hey.
Yep.
And then do I have to do that?
Just for the 4p electrons. Yeah. The 2 electrons. The 4p.
How do we do that?
Well, your energy level value is going to be what?
Or 4.
4, right? Anytime you have a P, your L value is
1.
1. And then your range of orbital values go from -1 to
So it's
-1, 0.
And then what's the difference between the -1? Oh, that's when you fill it.
They're both going to have the same spin.
Okay, can you
4
check this?
I'm going to put it on.
Ew.
My turn.
All right, so we need 4 additional electrons here, right? To get to germanium, 32. So here's going to be your 29th electron, 30th electron, right? After 3D, the next one to fill in is 4p. Anytime you have a p sublevel, how many lines do I draw?
1, 8, 6, 2, 9, 8.
I only have 2 electrons to put in there, right? They don't want to pair up because they have their own seats, right? So they're going to spin the same direction. So then when we write the notation, it's all going to be the same, except now we filled that up, right? We need 10 for P2.
Okay, actually.
And now we want the quantum number values, right? But only for the 4p electrons.
Oh,
I only have 2 of them, right? There are only 2 electrons in 4p.
yes.
If it's 4p, they're both in the 4th energy level, right?
And then one.
My L value for p is 1, right?
And then it would be -1 and 0.
And then my orbital values would be -1, 0, and 1, right? So I'm just going to use -1 and 0 because I ran out, right? My 3rd orbital is empty. And since they both went in occupying their own orbital, they're both spinning.
I did it
Makes sense?
So the only question I have is for the
What?
L, how do you get the one? So how do you get the one for the 4?
Here?
Yeah.
Okay, so an S
When was that?
sublevel, guys, listen up, please. An S sublevel always has a value of 0.
Okay,
Any P sublevel is 1, any P is 2.
Ah,
And you'll never go beyond that, because we'll never get there.
that was pretty crazy.
All right. So I can move on to shorthand notation, or I can just give you the rest of the period.
Oh, I give us the rest of the period.
That's where I ended with the other class.
Oh, I agree.
Yeah, and
I think that's enough to digest in one.
I think.
okay, so tomorrow are we gonna